Now this sum is a very famous sum, has been asked multiple times in the Cbse or the board examination, and it's a previous year competitive level sum as well. According to it, we have 0 to pi upon 2 log sin x dx. We may be asked to evaluate it, or we may be asked to prove that this is same as 0 to pi upon 2 log cos x dx, and this is equal to minus pi upon 2 log of 2. We have discussed earlier also, when we write log here in case of calculus, by default this base is e. So here we start with it. As usual, I'll be taking this portion as I. So we have 0 to pi upon 2 log sin x dx. We take it as the first equation here. If we apply the sixth property as usual, according to it, we just need to replace the variable which is x present in the function by the upper limit minus x. So we have pi upon 2 minus of x to be written here. So this is by using the sixth property. According to it, 0 to a fx dx is same as 0 to a f of a minus x dx for the definite integrals. So we have 0 to pi upon 2 log sine pi by 2 minus of x makes it cos x, and this equation is taken as the second equation. So we have the given quotient, we assumed it as I, it is 0 to pi by 2 log sin x dx, definite integral, and on application of sixth property has been converted to I is equal to definite integral between the limit 0 and pi by 2 log cos x dx here. Simply add both these equations. First equation plus second equation gives the left hand sides on addition gives us twice of I. The right hand sides on addition, I'll be doing directly now. You can observe we have the right hand sides, they are the integrals within the same limits of integration. So I'll be writing the sum of log sin x and log cos x under a single integral sign. So it is 0 to pi upon 2 log sin x plus log cos x dx that we get from here. Now here we make use of the property of logarithm, the log of m plus log of n is log of m multiplied by n. So this integral becomes 0 to pi upon 2 log sin x multiplied by cos x. This sum is done in a specific manner only. So look at the solution that I'm developing, and after that you try to do it on your own. And writing it multiple times will increase your confidence and you'll be able to write it accurately. So log m plus log n is log of m multiplied by n. This is what we have written. Now here we have a very important step. Here at this stage we will prefer multiplying and dividing by 2. Same is indicated by blue here. So you can observe we have 2 sin x cos x here. 2 sin x cos x stands for sin twice x. So the integral becomes log sin 2x upon 2 within the limit 0 and pi by 2 being integrated with respect to the variable x. Now again we have another formula for log of m upon n. So log of m by n is log m minus log n. So I'll be doing two things simultaneously. I'll be writing the formula for log of m by n, which is log m minus log n, and I'll be splitting this integral into two parts. So log sine 2x I'll be writing as the first part of this integral, and from there log 2 within the same limits of integration, we take it as the second integral here. So till now we get this equation. In the second part you can observe log 2 is a constant. When I bring it outside, so we'll be left with 1 inside as an integrand. Its integral is going to be x, and upper limit minus or lower limit in that case gives you pi upon 2, and log 2 is already in product. So this integral takes a form twice of I equals to 0 to pi upon 2 log sine 2x dx minus this log 2 being constant taken outside, we are left with 1 as integration x, upper limit minus lower limit, in that case makes it pi by 2. So I can write pi upon 2 log 2 with the negative sign of course in between. Now most important thing at this stage is I want you to look at the things very closely. What they are asking us to prove is minus pi by 2 log 2, and while solving we already have reached this stage, minus pi by 2 log 2. Now we have 2i is equal to 0 to pi by 2 log sine 2x dx and minus pi by 2 log 2. I will prefer taking this integral as I1 for the time being, and this minus pi upon 2 log 2 will be writing as it is. Now imagine when we have started by taking or assuming this integral as I, our aim is to prove that I is equal to minus pi by 2 log 2. As of now, we have 2i is equal to I1 minus pi by 2 log 2. Our answer is here, but this 2i, it should be I, and this I1 should not be there. So if we think closely, if we can prove that this I1 is same as I, if we can prove that I1 is same as I, that I can be shifted to the left hand side, it will become minus I. 2i minus I makes it I, which is equal to minus pi by 2 log 2, and we will reach our final answer. So at this stage, I take this equation as equation number 3 and start my work on this I1. I1, I have to prove that this is same as I, and what is I? It is 0 to pi by 2 log sin x dx. So I1 at the moment is 0 to pi upon 2 log sine 2x dx. If you compare, what's the difference between I1 and I? Is it the limits that are different? No, limits are identical. Log is also same. Sine is also the same. We have the sine symbol here. Dx variable is also the same. What's the difference? You watch it carefully. We have 2x here, whereas in the function we have x. So we need to convert it from 2x to x. I can't write 2x is equal to x, but I have to make use of some other variable. So my substitution here goes like this. Let twice x be equal to t. Differentiating, we get twice dx is equal to dt, or dx is equal to dt divided by 2. So this is now the next level of I1. It is modified. Here we have log sine. I have taken twice x as t. So it is t here, and for dx I'll write dt divided by 2. Since it's a constant, I'll prefer writing it outside. Now, most important factor to be kept in mind here is once we have introduced a new variable, we need to modify the limits of integration also. Now you can observe this is the variable x, which is assuming value 0. When x takes a value 0, you feed it here in the link that you have established between the old and the new variables. So when we take x equal to 0, the corresponding value of t that we get is 0. And likewise, when we take the upper limit, means x takes a value pi upon 2, t becomes 2 times of pi upon 2. So t is equal to pi. So what we get from here is lower limit remains 0, t is equal to 0, and the upper limit gets modified to pi. Earlier it was pi by 2. Now by using the first property of definite integrals, according to which we are free to change the variable without altering the limits or without amending or changing the limits of integration. So I can write half as it is, 0 to pi as it is, log sin x dx. Only variable t has been converted to x, just like t is equal to x and dt is equal to dx. This is for our own convenience and it is as per the first property of definite integrals. Now let us now talk about this portion. Now this portion, if compared with I, it's not matching with I. Why? Log sin x is there, it's okay. Variables are also identical. 0 is there as a lower limit. Pi is there as an upper limit, but it's not matching with the upper limit in case of I. So here it is pi, but here it is pi by 2. So can we now think of converting this pi to pi by 2? Is there any rule which helps us in converting the upper limit of integration to its half? Answer is yes. The property is 0 to 2a fx dx is equal to 2 times of 0 to a fx dx under what condition? Under the condition that f upper limit minus of x gives us the same answer as fx. That means if I replace x present in the function by upper limit minus of x and I get the same answer as fx, then only I am entitled to take this 2 here in product with the entire integral, and thereby modified form of limit of the upper limit will be half of the existing limit. So let us observe, is f2a minus x same as fx for this function? In place of 2a we have pi. So if you wish, for your convenience, you can write the same thing as 2 times of pi by 2 also, but it still remains pi. So all we need to check is whether log sin, in place of x you have to write upper limit, whether you write 2 times of pi by 2 or you write simply pi minus of x. Sin pi minus of x, it is sine of x only. So we get log sin x, which is the original function. So this property is true, it holds true. So here at this stage we'll be able to bring this 2 here, and the modified form of I1 now is half here. This 2 times of pi upon 2, from there we can pick 2 in product here, and we get 0 to pi upon 2 log sin x dx. Now this 2 and this 2 will get cancelled. 0 to pi upon 2 log sin x dx is where we started. This is same as I. So if I take this equation as the fourth equation, I'll simply prefer writing using equation number 4. According to equation number 4, what we have proved, we have shown that I1 is same as I. So I'll be using I1 is equal to I in third. So when I use I1 is equal to I in third, this modifies to twice of I is equal to I minus pi upon 2 log 2. This I can be shifted on the other side, becomes minus of I, 2I minus I makes it I. So final answer is minus pi upon 2 log of 2. So it is minus pi by 2 log 2. This may be asked to evaluate. They may give you this portion only this portion to evaluate, or the other thing is they may give you this present format, that 0 to pi upon 2 log sin x dx is same as 0 to pi by 2 log cos x dx is minus pi by 2 log 2. One very simple reason is 0 to pi upon 2 log cos x dx. What's the use of it? Basically, they are giving a sort of hint or some initial direction that how this log cos x can be obtained from log sin x. So it is directing us towards the sixth property 0 to a f x dx is equal to 0 to a f of a minus x dx, so that we can write log cos x for log sin x after application of that property. So this is one of the most important sums asked multiple times in the board examination. That is why I prepared this question for you. I think you should note down all the steps very carefully and each fragment here, because this question is such a question which involves maximum properties. You have used, say, you have used the eighth property, which reduces the upper limit to its half, right? You have converted from t to x, the first property that you have used, right? You have used the sixth property according to which we have 0 to a f x dx is same as 0 to a f of a minus x dx. And finally, you're using a loop sort of thing, which is just like converting I to minus of I, taking it on the left hand side and then finally getting the value of I. So this is a single question which involves 3 to 4 properties at the same time. That makes it most important question from your board's point of view. So you should try it once or twice or thrice yourself unless you are able to write it on your own. You should note down the steps carefully. You can take a colored pen, highlight the steps. You can remember the steps wisely, carefully, and try to recall what exactly is to be written. And just like you can remember 4 or 5 steps in between, so you can do it in small fragments, just like from log sin x you have to reach log cos x, right? Then you have to add, then you have to apply the log formula, then you have to multiply and divide by 2, then apply log of m by n. So these kind of things you can write the outline for the question and develop the final solution. So over to the sixth question in this sequence.